Good morning, good afternoon, good evening. Welcome to another edition of the Level Up Hour here on OpenShift TV. I am Chris Short, executive producer of OpenShift TV, and we're joined by a very special guest today, but I will hand it over to the illustrious Langdon White to tell us what's going on.
Hi, everybody. So today as you can see on the screen, we have a very special guest, is Chris Wright. He is the Chief Technical Officer of Red Hat, and knows some technology stuff, and in particular knows a bunch of stuff about both Linux and Kubernetes. In fact, I think your Twitter handle is Colonel C Dubs, so it's kind of like he's kind of Colonel guy, knows a little bit of stuff, we brought him on the show, but we'll talk about kind of what we're like. First up, we wanted to talk about is that Red Hat Summit is coming up, and yes, JP Dade, I also need more coffee, as you can already tell. But coming up, Red Hat Summit is next week, and so we have that, and then immediately following that, we have KubeCon EU. And so we did our little contest for KubeCon EU, and I think we've identified some people who we want to give out some free tickets to, so we're pretty excited about that. As we have said on the prior shows, we have given all of you and everyone else free tickets to Red Hat Summit. So be sure to attend, because it happens to just be free. There's lots of good stuff coming up in the one that is coming up next week, where it's kind of like the way I've been kind of thinking about it is like it's focused on like keynotes. And so it's kind of all the big demos, big cool stuff that we're launching is all coming out kind of next week. And then the later one is kind of the more deep divey sessions. And then we should be doing one more kind of series that may, with any luck, be able to be in person, where we're going to do more like workshop-y lab stuff. And we're delaying that so long to try to make it in person, because obviously workshops are a lot better if you can do them in person. So Chris, what I wanted to ask you about or talk to you about is like, what are you looking forward to, next week, in particular, like you're talking. So what are you going to be talking about? Can you give us a sneak peek?
Yeah. Like, how do I keep from stealing my own thunder?
There is that. Yeah, totally.
So next week, as you described it, it's a little bit more of the keynote type of format, a little bit more high level stuff, trying to give a sense of all the things that are going on that are Red Hat, relevant to Red Hat, and both in the technology space and even how we deliver technology. So some of the things that I'm talking about, Red Hat's focused on the hybrid cloud. We think a lot about the open hybrid cloud and where open source creates the sort of infrastructure, support, and capabilities for building applications and delivering them all across the open hybrid cloud. What's really interesting to me right now is that notion of hybrid cloud. It's not new. It's been around for a while. We've been thinking about it and sort of advocating for it and supporting our customers who are living that as a daily reality for quite some time. Today, and maybe we were kind of the early ones and the lone voice for a while. Today, you find similar types of concepts from public cloud providers and other software vendors across the industry that mostly focuses on your cloud footprint and your on-premises footprint, or maybe your cloud's footprint, because many larger businesses have relationships with multiple clouds. The buzzword, I can't say du jour, it's the last couple of years, whatever that is. I'm not, my French.
French isn't strong enough. Yeah.
Is about edge and edge compute. And so when you take that notion of hybrid cloud and say, well, you're going to have applications that run in different locations, and the consistency of your operational experience, the consistency of your development targets really helps build efficiency for the business in general. That is a lot of what I'm talking about, and how we extend hybrid cloud out to the edge and think about the edge as a location for compute. You'll see like kind of headlines in the news talking about, the cloud's dead, everything's moving to the edge, and whatever clickbait type of title. But the notion that compute is expanding out to this new location, and the purpose for expanding compute to that new location is connecting compute to data, either a producer or a consumer of data. And we've known for quite some time the value that data can bring. It's you can mine it for information and use that information to change how you run your business or change how you respond to particular events. I think that's really interesting. And then when you throw in another kind of hyped up technology buzzword, I live in a buzzword compliant world, so just in case you're wondering,
get your bingo cards out, folks.
That's right. That's right. 5G is also not brand new, but it's gone from people are just talking about it and anticipating it to early stage rollouts of new infrastructure to support the next generation mobile network. Yeah, I got it here.
I've got a 5G phone here. Yeah.
Questionably 5G with my quarter of a bar at this location.
Yeah, in my house in inner city Boston, it's it's pretty.
It's not pervasive yet. We know that.
Yeah.
But that connection of 5G, which is just a way to connect devices to networks. In the end, I mean, it certainly has some specific characteristics that are interesting. But when you bring together two different trends in the industry, you really unlock a whole new set of opportunities that don't make sense if you're just looking at it from one perspective or the other. And so a lot of that is what I'm talking about at the Red Hat Summit, and it's certainly an area that I'm super interested in because I like to think about how that impacts our world, our daily lives. I mean, you think you go back 10 years and 4G was new. Right. And cloud was basically new, and smartphones were new. And
now look at
it. Today, we take those things for granted in ways we couldn't imagine 10 years ago. Yeah, and so we're at the cusp of building what we're going to take for granted in 10 years. We're building those infrastructure building blocks today. And it's really fun to just sort of to try to imagine what will life be like.
We're already seeing it here in Detroit, right? So Detroit, if you don't know, folks, is where I'm from, and we have what we're calling a connected corridor, so that we're building out from downtown Detroit, where all the major, big three motor companies here in the U.S. are, all the way out to the research end in Ann Arbor at the University of Michigan. So that's a very long stretch of, quote, connected highway where autonomous vehicles are going to be tested, autonomous sidewalks, right? Like that's a new term to me, right? Like allowing traffic flow and it knows who and what is where kind of thing based off sensors in the area. That is the kind of stuff of the future that we're seeing popping up now here in Detroit. So I can't wait till that is the standard in 10 years, to be honest with you.
Yeah. So I want to continue this conversation a little bit, but I want to back up a half a second and just be like, could you define edge for us? Because I think it's one of those, it is a very buzzwordy term. And the reason I'm asking for the definition is not so much because of the definition, but because I want to know, what do you think of the aspects in that definition are the important bits, or what are the hard bits about what we call edge?
Well, it's not easy to define the edge succinctly unless you give a very abstract definition. But the way I usually describe the edge is it's not one thing. And the edge, it's sort of a matter of perspective. And I usually draw an analogy to an onion. At any layer you sit within an onion, there's an adjacent edge or a next layer. And so if you think about maybe that sort of mental picture of a sphere, in the center of the sphere, you could place something like a data center. Now, oddly enough, from a public cloud provider, putting a piece of their equipment in that data center looks like the edge of the cloud to the cloud provider, but it's in the data center from a data center perspective. So again, that's why the perspective matters. And as you kind of move out from that core data center, there's different hops in the network, essentially, that are locations where you can do computing. And so there's core locations, and that fans out to a slightly more distributed set of regional locations. And then eventually you get to things like cell towers and actual devices. And devices could be as sophisticated as a smartphone, which is, it's a powerful computer, to something really tiny like a sensor that might have a fixed purpose. And so that the edge is across that entire spectrum. Again, it's really important what your perspective is. The probably the most important part about what is the edge, it's the latency relationship to compute to data.
Okay.
And obviously within a data center, across a few racks with fiber connecting all of your servers, you've got a low latency connection, and I wouldn't really call that the edge. But the places where data is being produced or consumed, and how you bring compute to that location as you leave the core data center or leave the public cloud, those are different areas that we would define as the edge. And if you in some industries like the telecommunications industry, there's a more specific and detailed definition, which includes something called a provider edge. So the edge of the network that the network is a service provider for. So that's the edge of their network. And then the customer premises side, which is the first hop into the customer's infrastructure. And so from a service provider, you might think of like in your home, if you have a Wi-Fi router that's terminating a cable or something for your internet service provider, that box is called a customer premises edge device. And so again, it's all perspective. But and today we have open source code coming from Red Hat running in the International Space Station. So that's as far out edge as you're going to get when you get thinking about the Earth.
Well, I mean, we got the Mars rover now. So
the Mars rover, yeah. So
little helicopters out there, yeah,
pushing the boundaries of the edge.
Right. Yeah, I think actually the data point is particularly interesting, especially because sure, 20 years ago, the data sizes were also kind of non-trivial when you talk about the bandwidth we had and stuff like that. But now they're ridiculously large, right?
Yes.
When we're talking about doing like machine learning or whatever, dropping a terabyte of data on something for a problem is like, whatever, that sounds normal. And it still kind of blows my mind a bit, right? That, terabytes of data getting thrown around. I mean, I have terabyte hard drives, for crying out loud. And I remember buying my 500 meg, big spend hard drive. So I think that's the really good point, is like trying to make sure that you have the appropriate compute right near the appropriate data is at least for me, an interesting way to think about the edge. The only thing I wanted to do too was pause for a second, because I remembered that I forgot my super ugly slides. And so let's run through those real quick, just because otherwise it wouldn't be a show. So I'm going to try to do the share screen button thing.
While you're doing that, I just want to point out, it's talking about edge and data and big moving. I read an article last night where an Airbus 350 generates anywhere between 800 and 900 megabytes of data per flight.
Yeah, right.
Like just sensor data, right? Like parts failures, that kinds of things. That data is being analyzed. And that is just fascinating to me that, wow, one flight can generate almost a gig of data. That's impressive, right? Like, what can you do with that to optimize your fleet of hundreds of airplanes?
It's actually really, really interesting, because flights are there's a safety consideration, there's a business efficiency consideration, and when you get especially to longer distance flights, very subtle things make big differences. For example, fleets traveling across the Pacific from the US to Australia, there's lots of historic data, and different planes, even if it's the same kind of high level moniker, could be generated at different times. And they're not all identical. And just the chemical compound in the paint can change the weight of the plane, and it can impact which routes are accessible because of how much fuel they can fill into the wings. And so
it's nuts. It's
pretty
really
subtle.
nuts.
And of course, they're also collecting not just flight data, but weather data, because you're looking at where there's likely to be storms, and there's seasonal weather patterns that means it's more efficient to fly one route versus the other route. And that's all, those are just airplanes. Cars produce, you'll hear anywhere from 40 plus terabytes a day in data in a vehicle.
Wow.
And so yes, as Langdon said, there was always data. There were, I've dialed up and wondered if I'd ever get that floppy disk downloaded. But the data rates are so phenomenal. And when you think about the richness of video data and the different ways that you can apply computer vision to video data to discern something, people use video data when there might have been an easier sensor to give you pointed information, but with a video you can collect a whole set of, a whole bunch of information all at once, and it's obviously, it's high definition and a lot of data associated with a video feed. So it's really interesting.
We should really have the stat on hand of how much video data we're using right now, in fact. But consider, especially seeing as we're restreaming across multiple. I mean, I think part of that tendency too is also interesting because there's
600 megs.
Okay, all right, see 600 megs. So it's also interesting, like somewhere, I don't know, 5-10 years ago or so, somebody got it into their head that like we have enough hard drive space to basically store all the things that we can discover. We don't know what questions we want to ask yet, but let's make sure we grab all of the data so that we can ask whatever question we want to later. And there's a lot of really cool factor to that. There's also some questionable ethical factors to that. But, for the sake of kind of this show, right, it really just blows out the data problem, but also, gives us all kinds of really interesting new questions we can ask, and techniques we can use, right? So like, machine learning techniques or whatever, to try to extract knowledge from all that data,
Yeah.
Awesome. All right, let's hit your slides before
my awesome slide. So this is the Level Up Hour where we talk about kind of like why containers are interesting and why you might want to start using containers in your everyday, kind of life. A little bit focused towards administration or administrators, but also for developers as well. What I kind of comment on is like I use containers all the time now. Basically, anytime I do anything, it actually really annoys me if I have to like install something locally. And then kind of eventually what happens is as you start to use containers more and more, you start to realize that now you need to orchestrate them. And so that's where Kubernetes and OpenShift kind of come in, is that you want to, and we've even covered on the show, doing limited orchestration in like Podman, and then kind of as you scale up, right, you go to like Kubernetes or whatever for more orchestration, because they're difficult to manage, not because they're difficult to manage, but because you tend to have a plethora of them really, really fast. And if you've ever managed, 100, like virtual machines, how hard that is. And so the same thing happens with containers, except even faster, right? So that's what we talk about on the show. And this is our first slide, and this is our always the same second slide. I do hear from our brand team at Red Hat that we will have brand new fancy colors and graphics any day now. So as I think I've said once or twice before. I'm Langdon on Twitter with a 1, and Chris Short is Chris Short on Twitter with 2 S's. And as I mentioned earlier in the show, Chris is actually Colonel C-Dub. Is it C-Dub or Dubs? I can't remember.
Singular.
Okay. So like my fingers can type it, but I can't necessarily say it, right? And then you can also chat with us on our Discord, as Narendev asked this morning. Yes, we are having a show today. However, just fair warning, because of Summit and KubeCon, we will not be having shows next week or the week after, but then we will be back with, I want to say, Container Health Index, I think, the week after that. I can't remember now. I usually look it up beforehand, but I forgot. I do not have, unfortunately, show notes from last time just yet. Unfortunately, I ran into some challenges yesterday on the personal life, and so just kind of ran out of time. But today we are talking about control planes and Red Hat Summit, and we're going to kind of get to that right now. But I'm not going to show the next slide because that's where we give away the points. Chris, when we get to that, we will explain the points if you haven't heard about them before. So basically, what part of the reason we invited you on the show today was because Red Hat Summit is next week, but then also you did a show with Kelsey Hightower. I think you recorded it a while ago, but then it kind of goes through the video editing process and all that jazz, and it's actually being released today on a series that we have that is like short segment, quasi deep tech stuff called Technically Speaking, and that episode's coming out today. We had a little teaser for it that we asked for because we decided that 7 minutes was or whatever it is, 7-8 minutes was too long, so we wanted to just do the highlights, but then what we want to do is we're going to show that real quick and then basically talk about the concept kind of a little bit more in detail. So Chris Short,
Yes,
you want to run our little video?
absolutely. Hang on tight, folks.
The whole point of this is that Kubernetes by itself isn't all that interesting. It's only what we do with it. And there's a few stories that come out of the box and you can read those, but they get boring pretty fast. But then if you look at it as a blank sheet of paper and you're willing to take all your expertise, so if you're a network administrator, maybe you go make a CNI plugin to take everything you know about networking and just abstract it away so that a developer who needs an IP address or to live on the right network segment doesn't really have to think about it. If you're in operations and you know how to roll out software safely over multiple regions, you can make a controller for that. You can name it the multi-region deployment controller and take all of your expertise, serialize it into that thing, and share with other people. And lastly, if you harness the power of open source, then you can get a whole community of people to do the same thing and then share that knowledge and propagate it through these systems, and we just happen to call it Kubernetes.
I'm seeing a new meme. There's an app for that. Now there's a control plane for that.
All right, folks. That was the sneak peek there. What'd you think? Let us know in chat. Definitely,
Exactly.
I will link up where you can find more of that in a second.
Yeah, so obviously we had a little bit of chance to talk about this before the episode today, so I kind of wanted to kind of walk into this is that one of the things that came up in that discussion is kind of this idea of Kubernetes as a control plane. And as we joke around about on the show sometimes, not everybody who watches the show has a computer science background. So could you give us a definition of what a control plane is? And actually that would really even be from an engineering background. We've kind of co-opted the term in the software world, but how would you define it? And I don't think we really care if it's a dictionary definition as much as to say this is what we mean in this context.
Yeah, it is a little kind of a nebulous term, although it's used really pretty consistently, especially in certain subject areas. I would say there is, when you think about applications or computer systems, there's two basic worlds. One is the world that's doing the actual stuff. Sometimes we call that the user plane. Sometimes we call that the data plane. Whatever. It's the place where your application is running and doing application-y things, business logic, manipulating data as it's flowing through the system, et cetera. You also have something that decides when, where, and how things get done. And that's more the control plane. So, some of the orchestration conversation bit around what Kubernetes is for containers, the Podman to Kube kind of bit that you were highlighting earlier. That orchestration is a form of control, and that's what we would call control plane activity. In the setup of a networking connection, you have some oversight that's ensuring that you connect the two ends, and then the data flows through the system. So there's a control plane element of how do you set the whole thing up. Maybe that's authentication to the system, maybe setting up a handshake to do encryption, and then you let the data flow. So another example of just how there's a control plane element that's controlling what's happening, and then there's a user plane or data plane that's doing the actual low level work. And Kubernetes combines the two. So in the show with Kelsey, we're kind of deconstructing that back to what are the differences. And almost always we think about the user plane. Most of what we spend our time on is writing applications. The applications do the application logic. But it turns out managing things, controlling things is hard. I mean, it's why Kubernetes exists. It's a real challenge to build, especially when you think about distributed systems. How do you manage, orchestrate, control a large scale distributed system? Well, Kubernetes does that.
And it's also, I think it's even harder because control planes, at least in my experience, right, they also tend to be like fractally, in that, it's like kind of no matter how deep you go, there's another one, and so because of that, it's kind of like, it's like recursion, but the opposite, in the sense that, it's like you have, you have to orchestrate or control or manage or whatever at kind of all these different layers all at the same time. And so I find that also particularly challenging about doing kind of the software systems that manage those things. And so I guess kind of when you were talking about it with Kelsey, I think the idea was that, so we have this control plane, right, called Kubernetes, but okay, so so we have this thing that can run cloud native applications, but I think the idea that you were discussing was that maybe it could be more.
That's the crux of the conversation, and it's fascinating. I mean, it's not meant to be a plug for the show, although you should certainly check it out if you're interested, but it's a fascinating topic. And it was really fun to have that conversation with Kelsey, who has been involved with Kubernetes for quite some time and has a lot of great insights based on his experience and the way his role at Google and the work that he does on a day-to-day basis. That probably the simple, like, so what, as I mentioned earlier, we spend most of our time thinking about the application logic, building apps. There really isn't an app that doesn't have some kind of controller associated with it, because you have to decide when to start it and when and how and why to run it, just to oversimplify it. And the focal point for Kubernetes, we recognize it as a way to deploy applications at scale in containers. Mm-hmm. And okay, so there's the orchestration of, if I spin up a container, it has dependencies of, it needs network, it needs storage, it needs to talk to these other parts of the application. Let's do the control plane work behind the scenes to make all of that work. And we want to make sure that it's got a number of instances, always. So if you want it to have 5 and one dies, you restart one. And there's Kubernetes is watching all of that and paying attention and just managing the resiliency and making so the declarative statement that you set out with when you said, I want this application to be deployed this way. What's interesting is Kubernetes has these primitives that enables all of that. And we think of Kubernetes as managing containers, which it does, but those primitives could be used in very different environments, even environments where there are no containers. There's no pods, it's like a very different world, which gets a little abstract and a little hard to imagine. But there are efforts in different industries where they spend all of their time focused on the control plane. And I've given presentations to teams that work on things like control plane systems for networks, and made this observation to those teams, like, hey, you're off there building something. It's pretty specific to your world. It's going to be a huge amount of work. you might want to leverage some tools that we've built in this toolbox that are going to make it so much easier for you to create what you're trying to do, which is intent-based or declarative, or, I want to just have the make it so button, and all of the control loops and sort of attention to detail that a control plane needs to pay to the user plane or data plane that it's controlling. And so we're just exploring, if you deconstruct Kubernetes to its core primitives, it has these notions of control, declarative state, control loops, or a controller, and then a really important piece, which is extensibility. So we understand well what it does for containers and pods and all of the infrastructure associated with applications, but we can extend it arbitrarily with the same rigor of creating APIs and declaring creating the declarative state for how you would like that system to behave. And you can build arbitrary control logic to witness the current state, understand your desired state, and work in a forever loop, reconciling the difference between your current state and your desired state. Basically, that is what a controller is doing. And it's fascinating because we don't think of it that way. And when you change your perspective and think of it differently, suddenly a whole world of opportunity opens up.
So I think, one of the things that occurred to me too is that, do you have, a little bit, do you have like a little bit of a challenge with having some of those conversations? Because there's like these classes of software problems or like things you want to go build that on the face of them look really easy, and then you get into it and you're like, oh my god, this is impossible. So like my first experience with this was writing a database. Basically way back in the day there were no in-ram databases in Java, so I was like, I'll just write my own. How hard could it be? And yeah, it turns out it's really hard. Package managers are in a similar vein, and something else that seems like a really easy on the face of it software problem. Orchestration, I actually think, is in that same bucket, right? Like writing a good orchestrator that is resilient and repetitive and always does the right thing is really, really difficult. And so I'm curious about, you said you've had some of these conversations with people about like kind of leveraging something like looking like Kubernetes in other kind of contexts. Do they kind of come back to you and be like, well, we can just write it ourselves, it's a lot easier, or it looks really easy? And how would you explain that conversation?
Well, the conversations are a little bit like what you described, but there's also another piece that's important, which is there's some sense of sunk cost. Like, hey, we've already got this far.
The sunk cost fallacy.
Why do we need to switch tools?
Right.
And that's a fair conversation, and it's just because something can do something doesn't mean it should, right? You got to weigh all the balances of risk, reward, etc. But so my experience has been mixed. So in some cases, it's just cute idea, clever abstract theory, never going to apply it. Thanks for the conversation, Chris. And other cases, it's eye-opening. Like, wow, that's actually solves a real problem that we were struggling with, and now we have a tool to solve that. And distributed systems are hard. There's a reason that there are academic programs that have been researching distributed systems for decades.
Right. They're straight up PhDs in just distributed systems. Right?
Yes. They're still trying to figure it out. Those are really complex systems. But if we kind of bring it back to something that's less abstract and very practical, I'll sort of oversimplify it, not for any other reason that's easier for me to explain that way. You think about a Linux system. When you start an application, we had a few different generations of systemd and upstart and traditional like sys5 init systems. There's the application itself, and then there's some custom logic that in the old days was a shell script, and now we've got service definitions and service files and things like that. But but that's custom logic explaining how you launch that application.
Mm-hmm.
And Kubernetes has that same capability already, and we use it every day. We use the underlying principles are things called CRDs, which would be custom resource definition, which is essentially an extensible way to build a schema that describes the state of the system that you care about, and then a custom controller associated with that CRD. Now you have a Kubernetes resource. It looks, feels, behaves like a Kubernetes resource, but it has this custom controller. We build the operator framework on top of that infrastructure, and now you have an operator, which is code, that can run an application in a specific way, including understanding lifecycle management, maybe backup, restore, the kind of auto scaling, responding to metrics that are specific to the application of, it looks like I'm, sort of not keeping up with my SLO, and so I need to add extra instances because throughput, peak load or whatever. That's already a control plane activity, and that's work that we do already. And the thing that I find kind of interesting and actually exciting, and it's a different take on the world, is that control plane activity, just managing a single application like that, an operator to run a database, and now your database feels like a database as a service running on Kubernetes. You're tapping into the intelligence of a human being, an SRE that knows how to set up and run a database, and you're codifying that intelligence in code to run the system. And
which is huge,
right.
like I don't think people appreciate
right
how,
there. It's a big deal.
It's a big
and
one.
then but wait, there's more. And then you could take multiple SREs from different perspectives, combine their experiences, and expand and improve that same operator, which is code. So now you're bringing an open source community aspect and code development aspect to operations. And how do you build and manage systems, which mostly open source software projects are about features, functions, capabilities, and it's like exercise left for the reader. How do you actually run that thing? Mm-hmm. And as you mentioned, you've got container sprawl or whatever you want to call it. Like it gets more and more complicated, even though the primitive is basic and easy to understand. Right. It just gets complicated because you have so many things interconnected and just the sheer volume. So you have to have code and automation to manage that complexity. And to me, that's why it's so interesting. There's this whole world that's opening up that's about community development, collaboration, making operations really a first-class citizen in the world, which is also including the control plane systems that are what operations teams depend on to run and operate infrastructure and platforms and systems and all that. So
it's really interesting. I mean, because what I never really thought about this before, but it's one of the things that I would regularly talk about when talking about like modularity and app streams was basically being able to, or even like some of the earlier things that we did that were similar, is like one of the things that's really nice about RPM, Deb too, right? Just package managers in general, is that you can encapsulate, there's some expertise encapsulated in the packaging format that you are benefiting from. The problem I was highlighting with like modularity was that it's not very discoverable. So, if you want to run an Apache web server, for example, on RHEL, you just, yum install HTTPD, right? However, if you want to host your HTML pages out of people's home directories, you have to go and set up like public HTML directories and all this stuff. In fact, there is actually a package that does that. That will set it all up for you based on, the guy whose name is Joe Orton, who sits in England, who's like an Apache expert, who knows how to set it up. But knowing what that's called is very, very difficult. And so it's kind of like a smattering of those operations that you're talking about, right? Because what's so difficult about our operational environment a lot of the times these days, right, is like, we're all building on the shoulders of giants these days, right? So as a result, we have to run all of these relatively complex systems before we even get to our code, right? Like databases and web servers and, caching servers and SSL termination and, every other thing. And so, like, kind of like RPM, encapsulating that expertise from somebody who knows what they're doing. And then what I think is particularly interesting, which I hadn't thought about it either before, is that idea of there's now can be a community around that expertise and actually have the arguments and the fights and the whatever about the best way to do it. And then, but then actually I can just take advantage of it, right? I don't need to actually understand how to run a MariaDB well, right? I can run one on my laptop, but it's not going to be robust, right? So I think that's really interesting. And I think that's, I don't think operators get enough of that credit, because, maybe it's partially just because they're so new, but let's, I guess what I would kind of wonder then is like, okay, so here is this brand new concept really, that has been enabled by the extensibility, flexibility, whatever you want to call it, of Kubernetes, because it's a control plane that allows for other control planes. What do you foresee other things that it could do like that, or what kinds of problems do you think could be solved this way?
Well, there's some self-serving stuff that we could focus on, which is, if you think about the primary focal point for Kubernetes is running applications across a kube cluster. How do you run collections of kube clusters?
Right.
So it's self-serving in the sense it's very Kubernetes centric still. It's not like branching out into completely different worlds. So really, really easy example, or something that I'm curious about is take a system that's a kind of a complex distributed system that's not about only containers running on Kubernetes. So maybe Edge. There's a set of devices that run off cluster. Those devices could show up as Kubernetes resources, and you could manage and control those devices. And you could even use something like a type of controller that's built around an Ansible runtime, so that your sort of control plane loop is an Ansible playbook. So you don't have to invent something entirely new or write something completely in Go, for example. And now you could create a system that has maybe some core logic and some sort of traditional applications running in containers in the core cluster, and then a representation of a whole bunch of off-cluster resources that you're managing and giving sort of an integrated view of your whole system from this single control plane. Keeping it sort of practical, like these are things that people have to do already today. Other examples might be, you want to leverage just a SaaS service that it's somewhere out there. You can build a resource that's a proxy for that service and create policy and a control plane around how you access that service as a custom resource. And again, it's a real thing. Applications today have to coordinate some of their work with a SaaS service. It's just part of
more
life.
And more, like huge amounts.
How do you bring that into one framework and make the point of doing that would be so it's easier, so it's better, faster, cheaper, whatever. There's a lot of just those sorts of opportunities that I think are the easiest ones to get started with. And then the bigger, kind of what abstractly could you do with a generic control plane? Control plane logic itself is often a pattern, and you've got some notion of resources and inventory. You've got some notion of a feed of data. You've got some notion of actions that you take based on certain events. That there's some common patterns there that you could apply to a whole set of different domains that is where it does to me get really interesting. But Kelsey had an idea of it's just a physical world. So you talk about the IT OT convergence, which is another buzzword, where OT is operational technologies. Operational technologies would be like where technology and the real world meet. So servo motors connected to a network to change the flow of air or liquid through a pipe or something like that. That's an operational technology. You could imagine a world that's really just managing physical infrastructure, but a control plane running on Kubernetes. So there's no the application is like your factory. But the control plane is supported in Kubernetes, and a very different look or view of the world from what you think about Kubernetes and running pods and applications in containers.
So we have a question here that I think is kind of relevant. Do you think there will be, or are there already, other Kubernetes distributions similar to OpenShift but serving a different purpose in user? To which I would say there's different versions of OpenShift to an extent, right? Like different, footprints that you can use for those purposes. But like when I think HPC, like the supercomputers, right? Like I don't think those are running Kubernetes, right? Like, or are they? Some are, some aren't, right?
Yeah, not pervasively. It's not the norm. So first to answer the question, yes. I do think there will be a way to build Kubernetes distributions that focus on particular areas. And you could say OpenShift has a focus on the enterprise and enterprise applications to make it super broad. But pick a specific use case, and it's already a possibility, and you already see that to a degree. Scaling Kubernetes up or down, tailoring it to a particular form factor. Some interesting stuff at KubeCon around Cube and home automation.
Right.
Very much not an enterprise world, just a very different application. So yes, I do think that's a reality. And I liked Kelsey's description of Kubernetes comes with some out of the box stories, like how to run applications. But you get, if you think of it more of as a blank slate, you get to create your own stories, and that's where it gets interesting. And it can do lots of other things. So absolutely, when you get into a space like HPC specifically, there's a world that's focused entirely on scale and performance.
Right.
And the IT world evolution went through a virtualization phase, which really didn't support the needs of HPC.
Yeah.
Virtualization creates overhead, especially in the IO path. And if you're trying to squeeze every cycle out of the system, you don't want to include any additional overhead. Containers don't introduce that same type of overhead because the application is confined into a namespace and resource controlled with secrets. But in the end, it's just an application running directly on the Linux kernel underneath.
Right.
So it's a better technical fit to the HPC world. But then you have this whole generation of stuff that's not needed Kubernetes.
Right.
And it's taken on a life of its own. There's grid schedulers that do very specific and specialized type of scheduling. Kubernetes' ability to be tailored to specific scheduling requirements is an example of how you could see these worlds coming together. And then the HPC world itself is evolving to take on more and more GPU accelerated machine learning type workloads, which is already something that we focus on in the Kubernetes world. So you see these places coming together. So I think it's really interesting.
Yeah. I envision, right, like all GPU clusters at some point, right? Because that's the use case they need. They might have a small, CPU to kind of manage the muckery of the platform, but all the work is being done on, some NVIDIA GTX, whatever, or RTX kind of card, and letting it rip because they just process things faster, right? Yeah.
Work that way already. The host processor is doing more than just placing workloads because it is optimized for a certain type of math.
Right.
And so, but that control plane logic of place the vector processing on the GPU and the integer processing on the
CPU.
on the CPU is like, again, oversimplified, but just an example of how you could imagine systems evolving. So yeah, absolutely. I think it's a really interesting space, and there's this convergence of use cases that draw towards, okay, maybe Kubernetes could be a really useful tool for HPC, and maybe there's a scheduler and a set of resource controllers that are very GPU centric and connectivity centric that would be the right way to tailor a kube distro for HPC, for example.
Right.
I mean, I haven't given it a lot of thought, but
yeah,
good example.
Yeah, thank you.
Cool. Was there more questions or?
No, I mean, that was the only one I haven't been able to answer. We've been talking about CRDs and operators and deployments versus deployment configs and routes versus ingress, things like that, right?
Well, so I did have another, this is a thought I've kind of had for a while, is like, what would you say, is there a strong, good comparison between like the Linux kernel and Kubernetes? Because in my mind, at least, right, they share a lot of similarities. And, I kind of wonder is like, could the Linux kernel essentially evolve into being something like Kubernetes, or I don't know if vice versa is quite the right word, but like, or some amalgamization of the two, because like you have a lot of the same goals in the two different pieces of software. I'm just kind of curious if you had thoughts on that.
Well, I mean, they live at different layers in the stack, and so there's probably real value in keeping some separation and allowing these two independent layers to sort of evolve on their own, but they're tightly interconnected. And the way that you leverage the underlying operating system at the kube level is direct. I mean, it's a one-to-one mapping. You do a little bit of setup, you create a namespace, you do some resource allocation and set up the resource controls around those resources. You pull an image, you make sure it's connected to some kind of a virtual switching infrastructure and connected to any PVs that it might need, the storage side, and then you launch the application as an application running on Linux. I mean, it's just all that stuff sort of disappears, and now you have this little vertical slice of your own Linux host sitting underneath you. And so are there specific things that we can do between the two projects to advance them both? Absolutely. And it's part of why, I mean, I don't mean to make it a commercial for Red Hat, but it's part of why we deliver OpenShift integrated, because we deal with this every day. We've got dependencies, capabilities that are driven in the kube layer that create dependencies on the underlying operating system. Right. So we have to do that. There are extensibility notions in the OS and extensibility notions in Kubernetes, and they're not the same. And it's less clear to me where those intersect. And then you could imagine a scenario where you want to do an intelligent scheduler for Linux. Intelligent, air quotes, meaning you're gathering data, you're building a model, and you're making scheduling decisions based on that model. You probably wouldn't want to do that in the kernel because of the complexity of running like a machine learning infrastructure in the kernel directly.
I think you and I have had this conversation before, in fact.
Yeah, probably. Exactly. But if you extract that out, it fits a general purpose machine learning workload that Kubernetes would support well. And you want to have a feedback loop between that controller or that out of the kernel sort of scheduler hinter and the actual scheduler itself. So that there could be real tight integration between those layers. And maybe you're doing that because of all the applications you're running on Kubernetes, and you want to intelligently place them for resource consumption concerns. I mean, clouds aren't cheap. And if you don't pay attention to how you consume cloud resources, it can get really expensive really quickly. So it's not just turn it off when you're not using it, but also optimize it when you are using it. And just some interesting potential examples. There's also networking and storage and observability, where with a building block inside the kernel like eBPF, what could you do that's connecting those different worlds? Observability is a critical part of any operations and understanding big distributed systems. And we have this tracing infrastructure that eBPF can support, and you can tie that back to a specific IO path for networking or storage to give instructions back to a program that might be doing NCAP, DCAP, or something pretty straightforward at the networking layer.
Right. It's funny because like the more I kind of think about it, or the more we kind of talk about it, or whatever, it's kind of like I get throwbacks to kind of relatively early in my career when we talked about heterogeneous grids. And that being like the thing, right, is that the way you could run a whole mess of workloads was by using all the desktops overnight, right? And then there was the I blanked on the name of it, but the AI the Search for Aliens app,
SETI
right?
at home, SETI,
SETI at home, that's it.
Yeah, there you go.
Or the protein folding one or whatever is like what you at least what I'm imagining you're describing, right, in a sense, like is we want that technology, that control plane or whatever, to be sophisticated enough that it can really make intelligent decisions about kind of how things are being distributed. There was also some interesting research that an intern of ours was doing at Red Hat, but they were like doing the research at Boston University, basically where they would look at the various providers doing serverless functions, so like AWS Lambda or Google Functions or whatever. And they would actually price comparison them based on the workload. And so because you pay differently depending on the kinds of resources you use, and so they would actually pick which cloud to put it in based on the workload that was being driven, so that they could get the cheapest price. And obviously if it was research, more that it was like something that you could fire up and make work. But they had working demos. It was pretty cool. And so you can imagine that optimization, right? And that's and kind of going all the way back to the very beginning of this conversation, for me, that's hybrid cloud. Like, is that I don't know where this stuff's going to be running, but it's going to be running somewhere, and I have guarantees on its performance. And to some extent, I get to the point where I don't care where it's running, which I know is difficult for most ops people, but
but it's terrifying on one level, and it's not just performance. It's like there's policy compliance around where data sits, and data sovereignty and data governance. Like there's a whole set of things that could become constraints around how you build this system. But if you can define clearly those constraints and understand how they're managed, everything that's within bounds becomes within bounds, and you have a real flexible system that still is operating within performance promises and data compliance promises and all the things that are important.
Well, I remember Gmail actually had a huge problem. They wrote some articles about this, is that they couldn't meet the, I think it was the EU at the time, requirements about where data landed, because they didn't actually know where your actual email was. And so,
I have the same experience.
Well, that's a different problem entirely. So I don't know, super interesting. So let's transition. I think it's kind of a good pausing point. We're almost out of time, and we can talk about some internet points real quick, and then we can kind of wrap up the show.
Chris, do you have a few more minutes to stick around, or do you need to jump?
Yeah, how fast do you need to?
I think I can stick on a few more minutes. Yeah, no problem.
Cool. Because I think this is hilarious, so hopefully you will too. We'll see. So I'm going to share the slides again. On this show, we give out points for kind of watching the shows and filling out some codes and making suggestions for the show and that kind of stuff. And so then every time we have an episode, we give out our sweet internet points, which at the moment only have intrinsic value. But we're joking around about our liaison who keeps telling us the same story about where we're going to get to extrinsic value. But so Narendev, top of the stack with 5,000 points, Netherlands Hackham, and Chris, just by way of explanation, we have completely made up how to pronounce people's nicknames. So, there's some backstory, but basically what I do is with the forum, to kind of protect some privacy, I give people a place to just say, give us a name to say on air. And so we have Noah Friction with 3,800 points. Netherlands Hackham with 4,900 points. And then Joe Fuzz, who still seems to be a little MIA. We need to know why they are not submitting points.
If you know Joe Fuzz, reach out to him.
Right, exactly. And then we have Detective Conan Kudo, who is steadily rising through the ranks here. Mm-hmm. And then Bacon Fork, I saw them today.
Yes.
But they did not collect points for the last episode, so we need you to do that. However, I think I forgot to take my handy note so that I could put the points codes in. So give me 1 second, and I will do that. But I usually have the links pre-allocated, but that should be it. Chris, thanks so much for coming. We really appreciate it. I like when we can talk a little bit about, like the future, as well as kind of the practical of what we're doing. I'm really looking forward to Red Hat Summit next week. I hopefully everyone on the show is, in the audience is. And then KubeCon EU, despite the time zone, that looks like there's going to be a bunch of interesting stuff there. We're actually going to be running some office hours on the channel, but most of the regular shows aren't going to happen during KubeCon.
Yes, because most of those people are going to be in different time zone, theoretically.
Right, exactly.
Yeah,
exactly. So it's a little bit harder. It's harder to run a 9 a.m. show, when you're,
up at 5 a.m. Yeah,
right. So thanks so much. And I don't know, should we call it a wrap?
Well, there's one question, Chris, if you
Okay.
don't mind answering.
Sure.
Is your office always that clean? Because if you look at my office, it's not, right? Like people are curious.
If you notice, you can't see any of my office.
If I could easily move, like the camera's kind of in a fixed location. If I could easily move the camera, you would see the mess. You would see the mess. I mean, I got stuff on my desk, papers, random stuff. Like it's I mean, the honest truth is I don't do anything back there.
Right.
I do everything up here. So up here is a mess, and back there I can just kind of ignore it. And I did a one-time sort of pass to make it work for presentations. And
Nice.
No, I'm not a person who excels at cleanliness and aesthetics and design spaces and all that.
I failed that long time ago. Yeah.
Feng Shui, perhaps.
Yeah. No, but thank you so much, Chris. We really appreciate you coming on.
Oh, absolutely. I enjoyed it. And, KubeCon plug, Clayton is giving a keynote on control planes.
Right. Yeah.
Oh, cool. I think
totally check it out.
Yeah,
He
totally
digs into some details. He actually is going to talk about a project that he started, which is looking at Cube just as a control plane. So coincidental to the conversation that I had with Kelsey, but shows how much interest there is kind of percolating up around different parts of the Cube community. So cool stuff.
Neat. That is very cool.
Awesome. Well, thank you all for joining out there in the crowd, and we will see you here on the channel here in a couple, not a little under an hour. We're going to be talking about Day 2 operations, part 2 on the OpenShift admin hour next. So stick around. And when in doubt, subscribe to the calendar, because I know time zones are hard. This one will help you.
Quick like and subscribe.
And also, yes, follow us everywhere you're watching us, and hit that like button, please.
Right.
Thank you very much. Take it easy, everybody. Stay safe out there.
The whole point of this is that Kubernetes by itself isn't all